Welcome everybody. This is the session, the session about, just 1 second, about state of the art industry 4.0, readiness of real enterprise insights and consideration. And now there will be the speaker, and Valentina, the other co-chair, will present the next. Will announce the next speaker. Thank you very much to be here. I remember 15 minutes for each speech, and after 5 minutes for discussion. Thank you. Have a good job.
Good morning, everyone. The first paper is first result of a survey on manufacturing of the future. The speaker is Manuel Fechter from Fraunhofer Institute for Manufacturing, Engineering and Automation, Germany. Please, Manuel, the floor is yours.
Yeah, thank you very much for the kind introduction. I hope everybody hears me well, and a very warm welcome from Stuttgart in Germany. As already introduced by Valentina, our paper is about the first results we gathered on a survey we did together with our colleagues from the Institute for Computer Science and Control in Budapest, Hungary. Yes. Just to give you a short agenda of what I'd like to talk about, I want to start with the motivation definitions of why we did this survey, and I will follow up with the analysis of the results and then a summary and conclusion at the end. I think everybody is familiar with where we're living at the moment, what our manufacturing companies are faced with to react to diverse challenges in order to stay competitive. I think one of the most important stuff at the moment is having to deal with the economic crisis due to the pandemic. And there are a lot of several different drivers which are influencing production scenarios and production companies in their everyday life. And we just wanted to know during the survey how companies deal with it and where they see the future of their future manufacturing systems. If you look at the influence and the drivers for these future production systems, there's a manifold of different characteristic and technological enablers. So as already mentioned in the slide ahead, we have complex supply networks nowadays. We have changing purchasing behavior of the clients itself. We have, again, a very strong or a refreshing influence of politics. We do have natural disasters like pandemics with unstable economics. And furthermore, what you can also experience is we have a growing product and process complexity, growing customer expectations. We have, again, a still increasing globalization of markets and an increasing competition. Usually, and this is something we received over I think it was part of the last decade, where at least in Germany, we did a lot of research into technological enablers for changeability and versatility in production. And these 6 main enablers are the so-called modularity, universality, neutrality, mobility, compatibility, and scalability of your production elements to be resilient to all these different drivers appearing to market and to our production systems itself. So what does this mean for our future production system if we like to take these enablers and put them into our characteristics of the future production systems? As part of an ongoing research project where Christian and I are part of at the ARENA 2036 research campus here in Stuttgart, where we focus on the automotive production of the future, we consider that there is a certain need for human-centered cyber-physical production systems, so meaning that we need smart systems being reconfigurable to handle with the different influences. We certainly need the influence of IIoT, so Industrial Internet of Things. As I already said, we need continuous reconfiguration to be always at the optimal point of production. We definitely need some resource interoperability, so we cannot deal anymore with some dedicated production scenarios. We need, for sure, automation, at least in the high-wage countries like we have here in Europe and Germany. And one point which is getting more and more important is that we need flexible routing. So that means we cannot deal with single product production lines anymore. So we definitely need something to be independent of any takt time and independent of some product configuration to be capable of really to fast interact and to fast react to changes. Yeah, Our approach was that together with our colleagues from Hungary, we set up a survey structured into 4 different topics, which we sent out to like a bunch of companies all over Europe, and like to address the 4 main stages of general information. So this is basically about where does the company come from, what is the size, what's the interest of production, and so on. But yeah. Then we further consider future challenges and trends. So this is more like on what is driving us into our current situation. So like challenges of manufacturing companies at a global point and the actual measures companies already employ to face these measures. And 3rd section was about flexible production system. And this is mainly the focus of this paper, so I want to present right now. The second topic mentioned here is part of the investigation of our colleagues from Hungary, which will present their paper on a different conference over the next days. So our session is about, or our topic is about the industrial feedback on new production technologies, and this mainly focuses on on these production technologies we already considered on the right-hand side on the previous slide. So this was about, well, we wanted to go into detail about the modular production equipment and modular production cells. We wanted to focus this topic of routing flexibility. We wanted to talk about communication architectures in production and about reconfiguration of production layout itself. And yeah, every of these topics is further checked with different questions, and we try to get behind what companies think about, where they see benefits, where they see drawbacks, and where they are more or less also a bit unsure where this might lead to. So where did we start and how did we go? We considered that all over the 3 main countries we considered into this survey in Europe, which is about Hungary and Germany, for sure, because our institutes are based here, so our network and our stakeholder peers are quite the best into that areas, and Austria, which is because both of our institutes have good connections into it. We consider that there are about 30,000 companies in the industrial sector. We contacted, because of our customer relationships, about more than 2,000 of them. And in total, we got 72 responses on which this overall survey is based, and where we just took out the results of this section 3 of them. So you can see the total numbers from which countries we got which amount of responses. What we can say so far, and this is just to give you a short abbreviation, usually, and this is further important for the European funding of projects, usually talk about SME companies, so quite a lot, or quite a large amount of these companies which we received feedback of are from small to medium-sized enterprises or smaller medium-sized enterprises, larging from 50 to 500 people, and quite the majority of them doing serious production in small to normal lot sizes. So we are not, or we haven't that far tackled the mass production into India. And we also have not the single piece production, as it is always also part of consideration in research projects. So much being said about the companies assessed into our survey. Into this evaluation, we consider these 5 green highlighted questions here on the right-hand side. And we also have sometimes divided the question in 2 parts. So we have like a general information in the first place, and then we have like a more detailed look in the second part of these questions, where we can rate on a scale from 1 to 10. So we get in relative feedback on how much the companies, it's more like an open question, so where they position themselves and how they consider it. Yeah, these clusters later on have been, or these answers have been clustered later on. So don't be too curious if you see that all these answers are ranked depending on the median average. So this is just, we did after this. This was no bias or no framing we did in advance. This is just for us to get a better understanding of where companies rank themselves and what's the overall feedback of them. So my next slide will always consider one of these following questions, and I just made up some key lessons learned or some interesting to see points which I want to highlight here into the discussion. The further detailed explanation of these different points and their answers given by the respondents is inside our paper. And if you have further questions about this, just feel free to ask after in the Q&A session, or take a look at our paper or contact us afterwards. So the first question was about how would you evaluate the following technologies regarding the potential towards flexibility. And it's quite interesting for us to see, as we always consider modular production cells together in a combination of HEVs, that especially the flexibility, mobility of logistics is highly ranked by the companies considered into this survey concerning the flexibility reasons. And what is also was also hitting our attention when we looked at it is that the topic of modularization of production cells. So if you're looking into matrix production system or further reconfigurable production systems, company are in our estimation of how we look on these data are furthermore not sure if they should see there a benefit or not, because the answers are quite ambiguous. So it's more or less like one half taking big advantage or high advantage of that or high benefit, and the other one is just taking low into that. And so we haven't that clear answer into that, which is in our case, for sure a detail we have to take a deep understanding, because perhaps the companies don't understand it the right way. What is also interesting to see is that the standardization of production equipment, which we always consider to be a key enabler to make modular production cells and to make mobile production cells, is not that high in focus of the production companies itself. And this is also something I experienced when I talk to industrial peers, that they are not too much talking about a standardization into that. I have to speed up a bit. The second one was about how can modular production cells help your production processes, and the overall answers are quite positive. 75% think that modular production cells would be beneficial. So this is the first questions. And looking at the results, that most of the companies consider more variants to be produced on the same production system, and an easy integration is the key benefit they can take from that. What is also quite interesting, and what we see when we discuss with industrial peers, is that the space requirements for modular production are quite unknown, or at least hard to discuss, as we, especially as a research institute, don't know if we really do need more space or less space, and how this will influence production itself. So this is more like an open point and still open to research. Next point was about how can the flexible linking of production cells can benefit the production process itself. Here again, it's quite a common understanding that this might be beneficial for future production systems concerning resource utilization, lead times, and so on, and especially for, again, higher number of producible variants and a better scalability of the production volume itself. The next question was about flexible communication architecture, but as you might imagine that we're not just talking about modularity of production equipment, we're also talking about the communication architecture, which is crucial to be really that keen on fast reconfiguration. And also here, 2/3 say that a flexible communication architecture within production will be beneficial for the business. And what we find in here is what, at least for us, quite refreshing is everybody was talking about if you have like a proprietary system of IT, you might also have or gain higher power over your suppliers, especially into your supply chain and the purchasing and so on. But this is nevertheless the goal of the companies itself. So you can see here on the right-hand side, the median value and also the interest into the different companies is quite low to that. Yeah, and about last question we considered into detail is how can the continuous autonomous reconfiguration of the layout help you? And here again, about 71% say that this will be beneficial for their business. Concerning the continuous integration for new products and so on. Here again, the impact on space consumption and the impact on resources utilization is not that into focus here again. And so again, for us, it is a point we should discover over our next, learning from these results and going into our new research process and research project to consider this more in detail. Just as a summary, and this, I think this was more or less also the result of the study we did here in the first stage. We see that modular production cells allow a higher resource utilization and easy integration of new product variants and a bigger product portfolio. So this was a key starting point we got into this survey, and we can say that this was more or less confirmed by the company. So we are not on the wrong track, considered our research. This chart is also one chart we do have in our paper, and rank the different concept of production cell, flexible linking, and autonomous reconfiguration, and their impact on these different attributes. You might say that modular production cells might result in higher resource utilization, and so on. So this is more like always like it's well suited, it's partly suited, and not suited. So this is more a rank we did here. Yeah, again, the key learnings, the overall confirmation was quite high over these main topics I already said. And yeah, just to make it short and why we already did this, the thing is that we're still looking for the new production system, which might follow up the already existing and conventional dedicated manufacturing lines we have nowadays in automotive manufacturing. And we try to sum this up on this slide here on the right-hand side, where we gather from a very fixed dedicated manufacturing line to more like flexible reconfigurable manufacturing systems. State of the art should be more or less the matrix manufacturing system, which we nowadays have already in some part of the automotive industry. But again, we are looking into the future and what might be following up this. And we are making at the moment a big research project about fluid manufacturing system, where we try to use comprehensive use cyber-physical manufacturing system in production for the automotive use case. And we're also looking in what's coming next after that. So how granular can we get in our production system? What does this imply to our complexity of the systems? How far can we get into the autonomy of the configuration and so on? And so this is a wide field. I think I've already exceeded my time lab, but if you have further questions about this, feel free to contact us. These are my co-authors. So Christian is unfortunately not here today, but he's doing well, and also the other colleagues from Hungary and our supervisor, Thomas Bauernhanse, here from Fraunhofer IPA. So thank you very much for your attention. And if you have any questions, so let me know, and I try to answer the best.
I thank you very much for the question. It was for the presentation. It was very nice. Are there any questions from the public, from the people here?
There's one, I think, Rudolf. Yeah.
Okay. Did you see the end? The hand?
Yeah. Yeah.
Okay, so please.
Yes, this is Rudolf from Graz University of Technology. Hello, thank you, Mr. Fechter. Thank you for your presentation. What I expected is that you have more deeper topics. It was on a very generic level. My question is your wonderful survey, and there was, it's a pity that only 72 reflected and responded, but did you also answer more precise questions concerning, for example, what about collaborative robotics? What about cloud computing? What about edge computing? How do the companies see the future in using 5G? Much more precise topics than this flexibility issue that has been existing since, yes, 20 or 30 years.
Yeah, and unfortunately, that's a very good point. We didn't do this in first place, and we gathered these answers on a very generic level, which we then experienced when we looked into the detailed answers, that it wasn't going that well into detail as we expected it in first place to be, because a lot of these open text answers wasn't filled out. I think it's a pity of all these more or less semi-structured interviews you can do online. So that's definitely a pity, and we have no further insights, but we have a lot of discussions about the results, and definitely we want to go there in more into detail, but we have to follow up this on a second survey, I think. And yeah, and again, about just the 72 interviews responded. I think was at the beginning of the Corona crisis, and a lot of people had different and perhaps better things to do and to manage in the companies, and then filling out our questionnaire. But we are aware that we need further details and further insight, and we have to refresh and further ask into special topics like collaborative robotics and so on, like you already mentioned. So yeah.
Okay, this would be really nice. And
Yeah.
If you like, I could feed you with some material what we did. I'm running a learning factory in Graz, and we're dealing a lot of with these things. I've got a 5G campus. It's really troubling. I can tell you, 5G is sold very, very well, but if you go into detail, they are all not the distributors, and they are not able to deliver a sound campus. This is my experience. The same it is because it's really hard, tough. I have bad experience with collaborative robotics. It's a really tough safety issue and so on. And yes, there's a couple of fields we could exchange our experiences.
Yeah,
if you like.
No, really, I would appreciate it. It's the same for me. I at least did a lot of my cohorts. So beside that arena research project in here, but nevertheless, it's still after the technological feasibility, it's still a long way to get it quantified and to get it certified for production. And this is a big challenge all the end. And we're talking about generic topics for the future, but the bottom down shop floor level is quite a different one.
Okay, thank you.
Okay, thank you. And I think we don't have time for other questions, but it was a very interesting presentation. So maybe people can contact you in another moment. Anyway, 72 not number. I mean, on my experience, usually it's difficult to have a high percentage of answers. So maybe it's a good result. Also, there are many interesting things. Also, me too. Maybe I will ask something. And I thank you very much. If you can remain, thank you very much. If you have other, I know you maybe are in a hurry, but thank you anyway. Maybe at the end of the session, if there are still some questions, you can ask to our presenter. So maybe now there is the second presenter. Thank you very much, Manuel.
Thank you.
Have a nice time.
Thank you.
Okay, thank you. Bye-bye.
So the second paper is Industry 4.4 using innovative European firms, exploring their adoption and communication features through content analysis. The speaker is Michela from the Department of Business Organization, University of Tuscia, Italy. Please, Michela, the floor is yours.
Good morning, all. Thank you for the presentation. I'm Michela Piccarozzi. I come from University of Tuscia from Viterbo, and I share my presentation. Okay. So I'm very glad to present my paper, joined together with my colleagues Cecilia Silvestri, Barbara Aquilani and Chiara Cagnetti. And our research work focuses on the Industry 4.0 and the technology tools used in this domain. And in particular, we focus on the communication of these tools by innovative firms. And the structure of my presentation will I will briefly focus on some aspects of my paper, and in particular, I would like to highlight the aim and the questions on and some results and conclusions. Our research work starts from the analysis from the literature of Industry 4.0. It is a recent topic, but widely investigated in literature, and in particular, we underline that the study on Industry 4.0 starting from engineering domain and now coming also to a managerial field, a managerial aspect. And in particular, we focused attention on the aspect of the managerial aspect of Industry 4.0. And in particular, our research work focused on the enabling technology of Industry 4.0, and we want to underline the communication from firms about the use or the implementation of the tools of Industry 4.0. And in particular, focus on the literature, we underline a gap in the studies because there are a lot of papers studying the implementation, the characteristics, and the use of the tools, but there are no papers focused on the communication to, in particular, to external stakeholder of these tools. And starting from this gap, the aim of our research were to propose an initial exploration of this topic, in particular to try to understand how, in which way firms communicate to investors the characteristic or the use or the application of Industry 4.0 tools. And we focus in particular on the case of innovative firms. And to reach the same, the paper proposed two different research questions. The research question number one focus on the main tools used or in firms, in particular in the annual report. And the second research question focus while in the characteristic of the communication and of the sentences containing the keywords of Industry 4.0 tools. And coming to the methodological aspect, the methodology chosen for this research work analysis, in particular of sample of firms. And we selected the firms of the sample from the 2019 world ranking of the most innovative firms by Boston Consulting Group. And as you can see in the table 1 in the slide, we selected the first 10 European firms. And in the classification, you can see also the world ranking, the country of reference, and the activity, the sector in which this firm operates. For each firm, we download the annual report, and we create a database to improve the content analysis. The second step of the methodology focus on selection of the keywords, and in particular we focus on the main tools. We selected the keywords of the main tools used in referring literature. And so, as you can see in the slide, we start from artificial intelligence, machine learning, and so on. And we use these keywords to improve the content analysis. In particular, we search the keywords in the annual report, and we focus on 3 different levels of the improvement of the content analysis. First of all, we focus on the categories of the sentences which are contained the keywords, divided into risk, strategy, and environment aspect. Secondly, we focus on the perspective of orientation of the communication of tools from managerial or engineering orientation. And last, we focus on the temporal orientation of the sentences, past, present, future, or non-orientation. And the results was divided into 2 different sections. In the first one, we focus on the frequencies of the keywords found in the annual report with the content analysis. And as you can see from the table, SAP is the firms that refer the most number of keywords, and at the same time, artificial intelligence is the most referred tools. While in the second section of our results, we focus on the characteristic of the sentences, and in particular, we in the table 3 analyze the strategy, risk, or environment orientation of the communication. In the table 4, we underline the managerial engineering aspect of the keywords found in content analysis, and the last, the temporal orientation. While in the table 6, 7, and 8, you can find the classification of the single keywords, single tools in the 3 different perspectives. So strategy, risk environment, managerial engineer, or the temporal classification. Coming to the results, so some aspect of the results, we can first underline how most of the firms, 8 of the sample, refer to one or more Industry 4.0 tools. And the main, the mostly referred detail are related to SAP and Philips, so in industry sector in particular. And this is very important because Industry 4.0 was born in particular in industry and electronic sector. But at the same time, it's very interesting to underline how AXA, so insurance firms in services sector, refer to different use of the Industry 4.0 tools, so for 14 keywords. Coming to the 2 different research questions. From the first research question about what are the main user mention tools by firms, it's important to underline that the most used innovative tools or mentioned was the artificial intelligence, and this result confirms what emerged from the analysis of the literature. In particular, for example, Philips talk about artificial intelligence in their application, in the application of their activities, but also in the improvement of medical instruments or clinical decision support and so on. And machine learning is the second one tools emerge from the content analysis, and this is in line with the old history of machine learning, not only linked to Industry 4.0 domain. While a special mention deserves to Internet of Things, that is the younger instrument tool in this domain. And in particular, some firms define, like for example, SAP, define Internet of Things as the key to our strategy, so a very important tool in their activity. Coming to research question, we focus on the characteristics, in particular of the communication, so the detail of the communication. And first of all, it emerged from the content analysis that strategies is the main aspect, the main way to communicate these tools. So firms communicate the use or the application of innovative tools in their activity. But at the same time, it's important to underline how there are some references, some aspect regarding the risk and the environment aspect. In particular, focus on risks. For example, AXA talk about the stress, the risk appunto, associated with the managing of sensitive data. So focus on the topic of privacy in the use of technologies tools. And also risk is related to the use of the tools from competitors. So risk is at the same time linked to the core business activity. And for environment aspect, it is important to underline that annual report didn't focus on environment aspect. So to find some specific consideration, important to analyze, for example, the sustainability report of firms. But at the same time, emerge from the analysis some aspect of environment, but also societal implication of the use of Industry 4.0 tools. And in particular, for example, SAP, but also Philips refer to the use of Industry 4.0 tools to improve the sustainability, to improve the life condition of all day, for example, in improve of smart cities and so on. And for the other characteristics, it's important to underline that there are a prevalence of managerial aspect in the communication of the Industry 4.0 tool, and at the same time the temporal orientation is present or past, and this makes us to understand how today Industry 4.0 is consolidated the reality in the life of firms, in the core business of firms. And in conclusion, we can affirm that most of the European firms we choose in our sample pay attention from a communication point of view, so in the annual report at the use of the Industry 4.0 tools. And these tools are used and communicated in different sectors. So from insurance sector, like for example AXA, and traditionally in the sector linked to technology and innovation, so firms and SAP are the main example. And our paper provide both theoretical and managerial implication. From a theoretical point of view, it could be first study, first example of try to understand communication of these tools by firms to stakeholders, to external investors. And from a managerial point of view, the paper can offer support to managers to understand in which way explain and communicate to stakeholders the Industry 4.0 tools. The paper also provides some limitations that are linked to the sample selected, and at the same time to the improvement of the methodology. So the content analysis in some aspect have a degree of subjectivity from the researcher. And for further step, it could be interesting to add a sample more, to widen the sample of firms, and at the same time to focus attention also on the sustainability reports to underline the communication of impact in terms of environmental social aspect of Industry 4.0 tools. Thanks for your attention.
Thanks very much to you. What a very interesting speech. I would like to ask us if anyone has any question concerning the paper. Okay, I would like, if I have to see the hand. Okay, I would like to ask one thing. I think it was very interesting. As far as I see, you, as you said, you consider all sector companies, not only manufacturing companies. No, if I see, because you
yes.
told about AXA, because it was interesting. The first paper, they were concerned about what are the most interesting development concerning manufacturing industry. So it was speaking about autonomous reconfiguration, flexibility of the manufacturing facilities. But I don't know if you, when you searched the database, if you asked also how to use, for instance, artificial intelligence or internet in order to also to improve the manufacturing system. Something connected with also the first paper. Maybe is you told that is a managerial paper more than engineering, but I think it's also interesting to have some information. I don't know if you have any information. This in the sense all the 4.0 tools you considered. Are there any consideration how they can impact also the manufacturing facilities, the production plan?
No, there are no references in the content analysis. Some aspect from Philips, because they talk about production of medical instruments, support in production system of medical technology instruments, but there are no specific reference to the production system.
Okay, well, I think maybe in the future. Thank you very much. If there are other questions for Michela. Okay, no question. Thank you very much, Michela. It was very interesting. Also, you can contact her also outside the session, I think. We can carry on. Thank you very much. Bye-bye.
So let's go to the next paper, clustering and classification of manufacturing enterprises regarding their Industry 4.0 reshoring incentives. The speaker is Petra Unterberger from Salzburg University of Applied Science, Austria. Please, Petra.
Yeah, hello, thank you for the nice introduction. I try to share my screen. I hope you can see it.
Yes.
Okay, thank you very much. And also thank you to ISM 2020 for the opportunity to present. I'd like to welcome you to my presentation of the paper Clustering and Classification of Manufacturing Enterprises regarding their Industry 4.0 reshoring incentives. My name is Petra Unterberger and I wrote this paper with Julian Müller. The decision where to locate and relocate manufacturing activities has been an important topic within strategic operations management. Especially until about 20 years ago, there was a general trend to offshore manufacturing activities. This was due to lower labor costs, while transport costs in international container shipping were comparable low. In recent years, the manufacturing offshoring trend has been losing its speed. Supported by national initiatives to bringing manufacturing back to home countries and rising wages in countries such as China. Further, several risks are associated with production relocation abroad, such as lower quality, local conflicts, long supply chains with high reaction times, or skill shortages. A further potential risk of global value chains is especially highlighted through the COVID-19 pandemic. In this context, the productivity increase in Germany through Industry 4.0 and the higher flexibility requirements illustrate relocation factors that go beyond the financial perspective and represent incentives for bringing production back to the home country. This paper aims to explore which reshoring incentives are essential for different groups of German manufacturing enterprises. In order to meet this requirement as objective as possible, data-driven clustering and further classification are performed through a k-means algorithm and an inter-class variance analysis. Therefore, a questionnaire that surveys the reshoring incentives of 94 German manufacturing enterprises in the context of Industry 4.0 is raised. Since there exists no prior research that uses unsupervised learning within the reshoring context, this paper offers a novel approach how German industrial enterprises are clustered and further classified in regard to their reshoring incentives. I think all participants of ISM 2020 are well aware of the concept behind Industry 4.0. Therefore, I just would like to highlight the potential for increasing competitiveness in Germany along the economic, ecological, and social dimension. The term offshoring generally describes the relocation of activities from the home country to a foreign country. For the reversal of offshoring decisions, the term reshoring is used. Several authors claim that offshoring and reshoring face the same considerations regarding geographical and governance dimensions. These include strategic management theories such as transaction cost economics and resource-based view that are linked to the manufacturing location decision. In practice, reshoring is often a result of failed or unsatisfying offshoring results concerning costs or market motivations, having a long-term effect on the company's competitiveness. Further authors consider the consumer perspective nearshoring instead of long-distance offshoring, relating to perspective on strategic operations management. In general, empirical evidence on reshoring is low, while a large number of reshoring drivers are discussed in literature. Only few studies are attributed to the topic Industry 4.0 and reshoring yet. One of them is from Müller, Dozauer and Voigt, where they try to investigate Industry 4.0 and its impact on reshoring decisions of German manufacturing enterprises, which we use as a baseline due to the related research question. However, these studies provide an overview of potential reshoring drivers in the context of Industry 4.0, but not how those can be clustered, working out possible relationships. In response, this paper attempts to close the scientific gap by investigating the research question how German manufacturing enterprises can be clustered and further classified in regard to their reshoring incentives. Due to the novelty of reshoring and its limited as well as specialized research, a general clustering of manufacturing companies concerning the reshoring incentives is preferable as a baseline. While most classification tasks are exclusively based on theoretical prior knowledge in the form of labels, this paper uses unsupervised learning to keep the possibility open to recognize structure in the form of clustering in a data-driven way. This paper adopts the unsupervised k-means clustering algorithm. This algorithm aims to maximize the internal homogeneity as well as the external heterogeneity between the subsets. In this application, k-means aims to cluster companies that answer very similar to the questions, while also optimizing to keep companies with different answers in different clusters. To explore the optimal number of clusters, the elbow method is performed. The specification of the exact number of clusters is supported by a variance analysis of 100 experiments. On the basis of the data-driven generated clusters, the features determining a subgroup are analyzed to solve the classification problem. Therefore, an intra-class variance analysis with enrichment through prior knowledge is applied. To build on the current state of research, the questionnaire and sample of Müller, Dozauer and Voigt is used and extended by almost questions, resulting in 94 companies. The questionnaire includes the drivers for reshoring found in literature and the importance of Industry 4.0 for German as well as individual companies to reshore. The sample consists of manufacturing companies with at least partial offshore production. Data preprocessing is performed in terms of standardization. In order to check the results against bias, the state-of-the-art scientific process of feature selection is performed on an additional control dataset. The sample includes 58 different features, with the compared feature extraction process leading to reduction to 36 features. The main focus of this paper is to investigate the optimal clusters of manufacturing enterprises in a data-driven way with regard to their reshoring incentives, and further to classify them. Using the ELBA method and the robustness test, 5 clusters are preferred. The size of the individual subsets given by the k-means algorithm is also found experimentally on a basis of 100 iteration. As a result, the dataset containing all features is clustered into 5 groups, including 7 to 28 observations. To detect which features determine the individual groups, the quantile with the lowest intergroup variance is analyzed. The 15 features of each subset get ranked in regard to their divergence to the mean. The 5 most influential features in terms of grade deviation per subgroup are shown in the table. As illustrated, cluster 3 and 4 are distinguished by features that are above average importance, whereas cluster 2 and 5 are distinguished by features that are above average in importance, and that cluster 1 includes both types of features. Extending the 2-class problem to a 5-class problem, the claim of the baseline paper that innovators differ in reference to the reshoring incentives can be supported by cluster 3. The reshoring decision of these innovators is based on the extent of flexibility, utilization of new technologies, and domestic research and development. The counterpart of this innovation class is the traditional class illustrated in cluster 5. Domestic innovation, research or technology, as well as improved customer orientation through cluster. Further, a lack of trust and sustainability is decisive for reshoring. This claim is supported by cluster 4, which mentions the loss of know-how, legal certainty in Germany, and sustainable aspects as the most important reshoring incentives. This class of trust and sustainability concerns also has a counterclass, which has no trust issues in reference to reshoring. Neither increasing stability in the offshoring country, cultural differences, nor product privacy are notable advantages of reshoring for them. Cluster 1 is the largest, with approximately 30% of observations, and its features do not lead to a clear classification. Shorter time product, also shorter time from product development to placement as reshoring incentives. They take it seriously. Greater flexibility or improved customer service through geographical proximity have a subordinated role in their reshoring decision. With the resulting 5 clusters, the research question, how manufacturing enterprises can be clustered in reference to their reshoring incentives, can be qualitatively and quantitatively answered. These clusters enable the classification of the observation, so that cluster 2 represents the class no trust and no sustainability, cluster 3 innovation, cluster 4 trust and sustainability, and cluster 5 represents the class no innovation. Thereby, using the entire feature space, 4 of the 5 clusters can be classified, so that the research question, how manufacturing enterprises can be classified in reference to their reshoring incentives, is mostly answered. The resulting classes illustrate that the importance of innovation as well as trust and sustainability are decisive for the separation of German manufacturing enterprises regarding the reshoring incentives. The focus on innovation capabilities supports the finding that reshoring is strongly driven by Industry 4.0, since the German high-tech concept is based on the interconnection of state-of-the-art innovation in terms of the IoT. Additionally, the horizontal and vertical connection across entire value chains allows for great benefits also in social and ecological dimensions, so that the demand for trust and sustainability are additionally motivated by Industry 4.0. The aim of connecting the physical and virtual worlds must face the challenge of negative externalities and isolated companies that fear loss of know-how and an unequal distribution of costs and benefits. In conclusion, the main contribution of this paper is to cluster and classify German manufacturing enterprises in regard to their reshoring incentives. Using unsupervised learning in terms of the K-means algorithm for this purpose provides novelty, since the current state of reshoring research does not include unsupervised learning methods. This data-driven approach enables the investigation of unknown relationships within the reshoring phenomenon while confirming objectivity. Validity is supported through the comparison of the baseline paper from Müller, Dulzer, and Voigt, as well as to the approach using an additional feature extraction sample. Generalization for German manufacturing enterprises are possible through the sample homogeneity, despite the limitation in reliability caused by few observations and a single country. Therefore, it is further suggested to expand the sample size. Additionally, other clustering methods should be applied to detect groups of enterprises that differ in the reshoring incentives. Since the K-means algorithm is the most common clustering algorithm, this paper provides a suitable baseline for further investigations. Moreover, the motives and drivers behind reshoring could be further differentiated depending on the type of manufacturing process used for each product. Thereby, a deeper understanding and a more differentiated perspective could be established of which manufacturing processes are most relevant and relate to which kind of drivers. Yeah. Thank you for your interest. Now I am happy to answer any questions you might have.
Okay, thank you very much, Petra, for your presentation. Are there any questions for Petra? I see the hands. I have to see. Okay, I would like to ask you something about the paper. You told that 94 farms are a small few number of observation, but I don't think is. I think is a huge, but because I don't think it's easy to have many numbers of answer concerning companies. Another aspect, you in the conclusion you talking about the differentiation concerning the manufacturing process. You mean that in the future you can you try to make other cluster based on this part on manufacturing process, other clustering of companies, or is it different? Another point in the clustering you did in the of the companies. There were several many aspects, but not economic. I mean, the relocation obviously is not based on economic reasons. I mean, the reshoring is not based on economic. Is a quality, is a shorter lead time, but no economics. No, this is a discussion. The economy, the yes, the economy efficiency. Okay, thank you very much for your answer. Okay.
Yeah, concerning the number of companies, it's also a little bit complicated because you cannot use all companies. We use some with at least partial offshore production, and so it's already a little bit complicated to get a lot of number of companies, and this is also I think a challenge for your second comment which we also recommend to go into more detail concerning the manufacturing process, because then you need again more companies, but some of them have to be comparable in regard to their manufacturing process to get further details, of course. And what was your last question? Sorry.
When you made the clustering, I mean, in the slide before, there were many parameters, many aspects. I think. Other many aspects, but not strictly economic. I mean, I reshore because it's more convenient, more cheap. Is not considered, no, at the moment. It's not possible.
We also were surprised about this result, because we have it in the features asked, also economical aspects, because it's so important for offshoring. So we want to ask, but as you mentioned, it's not that important.
Okay. Thank you. Thank you very much. Are there any other questions? You can also, we can, if we will have time, we may have other questions. You can contact directly the author, because we have to respect the program. I thank you very much, Petra, for your presentation.
Thank you.
And also, as Petra, I would like to thank the organization ISM for this initiative that was very interesting. A lot of nice presentation. Thank you again very much, Petra. And I think we can carry on. I would like to thank again ISM and Professor Longo particularly for this interesting initiative. I would like to thank you all for this interesting session, all the participants. I would like to thank Valentina and maybe give it to her if she wants to also send as regard. So thank you very much. See you soon somewhere for in the future. Bye bye. Thank you very much.
Bye everyone.
Thank you.
Thank you.
Bye bye.
Bye.
Thank you. Bye.
Bye.